Phil's talk yesterday, and I'd seen on online he's been thinking interesting thoughts about some of the geopolitical aspects of landing on the moon and what the rocket plume exhaust does to the surface. And it's kind of things I think we should be thinking about, especially for inclusion, as we think about possible future missions or future opportunities that LPL might want to pursue. And so I thought we'd have just kind of an informal discussion of some of these things. And Phil has a few slides, but really isn't a talk. It's more of something to focus on discussion around. And so I thought we'd keep it really informal. Why don't we go around? We've already met Daniel. We can go around and just give a quick intro of who everyone is.
Hi, I'm Ryan Hahn. I'm a graduate student working with Lynn Carter on lunar volcanic features.
Great to meet you, Ryan.
Jess Barnes, assistant professor, cosmochemist, so working on lunar samples and all sorts of other materials.
I didn't hear your first name.
Jess Barnes.
Yes, great to meet you.
Pierre Haneko, assistant professor too, working also on cosmochemistry, but focusing mostly on meteorites and asteroids.
Awesome.
Hello again, Andy Ryan, staff research scientist working on atmospheric sample analysis and exploration.
I know Andy, we've worked together on a proposal recently. I submitted like 1 week ago.
I'm Daniel. I'm a graduate student from the physics department. I work with Rhythm Malhotra on orbital motion and lunar ejecta.
Awesome.
And Lynn, you want to?
Yeah, I'm Lynn Carter. So I work on mostly radars, but a bunch of radars of lunar surface. So
Awesome. Okay, I'm Phil Metzger, research faculty at University of Central Florida, retired from NASA. Mostly developed space technology, but I've done a lot of work on studying how rocket exhaust pollutes soil and then methods of mitigating.
And just complete Christopher, you want to give a quick intro to yourself?
Oh, Christopher Hamilton, having lunch. It was a brown bag after all, so I don't see too many other lunches. So mainly do planetary volcanology, but worked with Jessica on our Artemis 3 geology team proposal. And one of the things that we were quite concerned about was just how the surface could be disturbed, particularly during landing and takeoff, and how we might be able to sample some of the changes that would happen in the regolith in those areas. We've also used some LiDAR technology to be able to image the jet wash produced from drone props to simulate some of the effects that you could have for moving regolith and being able to identify those particles in motion. So quite interested in the subject. Nice talk.
Cool. Very much.
Oh, hi, I'm Thea. I'm a first year student working on thermal modeling of the Crossler Creek terrain with Professor Jeff Andrews-Hanna.
Awesome.
Yeah.
Hi, I'm Christina. I'm a first year grad student and I'm working on looking at mid-latitude ice sheets on Mars right now with Shane Byrne.
Well, great. Well, thanks everyone. So you want to take it away and feel free to, like I said, I just want to make this informal and kind of almost brainstorming, thinking about some of these issues. So go ahead.
Yeah, so absolutely feel free to interrupt. So let's talk. I'm going to try to go over geopolitical considerations of the plume surface interaction on the moon, an airless body, and efforts to mitigate the problem. But it's our common sense about this is very wrong because the moon is an airless body. And so the finest particles are what go the farthest and probably are going to be the most damaging. And the finest particles go globally because rocket exhaust exceeds lunar escape velocity. So it's not an issue of, we can't simply quantify the keep out zones based on how far the ejecta goes because there's no safe distance in that term, in those regards. But we have to base it on how far away does the damage become negligible. And that's extremely difficult to decide. And it requires coordination, international coordination to agree upon it. So it's going to be messy. So if you missed yesterday's talk, there's just a brief video of the Apollo 15 landing. You start to see haze as it's blowing dust. You'll start to see streaks forming. This is because of the enhanced flow around craters and rocks. Here's the shadow of the lunar module foot pad. By measuring the distortion of the shadow, we could measure the angle of the ejecta. Then you get a blast right here with some bulk material being thrown out. And then it took about 40 seconds or 30 seconds for the haze to clear exponentially. And we don't really know why it took so long for the haze to clear. It might be some electrostatic plasma effect because rocket exhaust typically is positively charged plasma. Okay. So anyways, that's just a super brief overview on the phenomenology.
Question?
Yeah.
So you're saying these particles can exceed the escape speed from the surface of the moon. By how much? Are we talking about few kilometers per second, tens of kilometers per second?
Good question, and good segue to this chart. So it's very controversial, actually, because we don't have any direct measurements of the speed of the ejecta. From that video, you couldn't tell how fast the dust was traveling. You can see rocks, and we can measure the rocks, and so we know the rocks are going 10 to 30 meters per second, and that agrees with our modeling. But for the smaller particles, we only have modeling, and the models disagree with each other. Published papers on this disagree by a factor of 10. And the reason it's so much disagreement is because modeling supersonic flow expanding into vacuum where Navier-Stokes doesn't work is really difficult. And trying to do it is a multi-phase flow with dense particulates that are colliding with each other, very broad particle size distribution. There's just no software that can do it. And so people try to approximate the modeling, but we don't know how to approximate it the right way. And so everybody gets different results, and we really need data from the moon. But I think it's pretty safe to say that the dust probably goes, there is a particle size that will get up to very close to the rocket exhaust velocity. If you have a fine enough particle, then its ballistic coefficient, its inertia is very low relative to the drag force. And so it'll very rapidly speed up to the speed of the gas. And so it depends on the rocket exhaust, the rocket propellants. In the Apollo program, they used Aerozine, which has a exit velocity of 3.1 kilometers per second. That's much faster than lunar escape velocity, which is 2.4. So there are particles, almost certainly there are particles being blown completely off the moon, and there are particles being blown to every distance on the moon. So we have some experience on this from Surveyor 3. Apollo 12 landed 160 meters away. The astronauts walked over and cut the camera off and some other pieces, brought them back. This lower part of the camera is shown on the right. Coupons were cut out from it and distributed to researchers. I had these in my lab for a few years, and we did an analysis using modern equipment, and which was much better than what we had in the 1970s. And so we could see from scanning electron microscopy, we could see the way the surface texture of the materials were crushed and filled with dust. We could see the paint was all cracked up. So I'm going to show a few more details of that. This coupon, let me just ask, well, so this is where there was a washer and a bolt head. And so this is the preserved paint. All the paint around it was colored tan. The astronauts actually talked about that as they were walking up to the vehicle. They were surprised how dark the vehicle was. And they were asking Mission Control, what color did you say that vehicle is? And they said, white. Why? What color is it? And Alan Bean said, it's tan. And so anyways, does anybody want to take a guess at what this crescent shape is?
Is it like a shadow, a dust shadow?
Yeah, it's a sandblasting shadow of where the bulkhead used to be. So when we analyze, so people used to think that the dark color was because of cosmic radiation darkening the paint, but we did some analysis of this, and we found out the shadow was actually lunar dust. And so the sandblasting from the Apollo landing actually was removing dust, net removal, rather than net addition of dust. And so the Surveyor had already dusted itself up pretty severely during its own landing. But we did see a lot of effects from the dust impacting it. This is where, I'm going to skip over this for time, but this is where we did the photoionization spectroscopy to prove what the shadows were made out of. We analyzed the cracks in the paint. We did laser mapping of the cracks, and there are these pinholes on the cracks. The pinholes are deeper than the cracks, and they typically meet, we map them, the pinholes are typically at the junction of cracks. So what it looks like is that the sand grain size particles penetrated the paint, and then the stress it caused to the paint sent cracks out. And so we could count the sand grains per square meter and estimate the amount of ejecta that hit the Surveyor spacecraft. But when we compared that to the optical density of the blowing dust, there's a factor of 1,000 discrepancy. There should have been 1,000 times more sand grains hitting the Surveyor. And the reason why is because simulations show that the ejecta flew harmlessly over the Surveyor instead of hitting it, because this was up on the rim of the crater and the Surveyor was down in the crater. So the simulations show the ejecta going over. And the only particles that hit the Surveyor were the ones that scattered out from particle collisions. And it was like 0.1% of the flux that it would have been otherwise. There's a lot more to those arguments, but also I have to acknowledge that these are all very crude arguments. We don't have great data from the moon on this. So everything I'm saying could be wrong. But this is the current best understanding of the situation. We also have evidence of Mars landers damaging themselves with plume effects. So Curiosity covered its deck with gravel. The Sky Crane thrusters in the thin Martian atmosphere were coherent long enough to reach all the way to the ground, dig holes, and then blow ejecta back out of those holes up to the vehicle. We can see it on Perseverance landing. You can see the vehicle being lowered down into the dust storm. You can see a rock. That rock, same rock was visualized by the Perseverance looking up as well. But so we can see pretty large rocks being blown. This is from Perseverance looking down. You can see that here's where one of the pairs of thrusters was hitting the ground, and here's where another pair was hitting the ground. And they're sending out these streaks radially, but the streaks turn away as they reach the center line of the vehicle. And so you get these two walls of dust. And these are called reflection planes. Whenever plumes interact with each other, they create reflection planes, and it turns the direction of the ejecta, and you get enhanced ejecta along those planes, and it can get higher elevation of the ejecta angles. And so it's nice that we got pictures of it happening on Mars landing, because we've always hypothesized this would happen on the moon, but we don't have direct evidence. I mentioned the Surveyor. This is the camera mirror, and it was so covered with dust that one of the astronauts swiped it with his glove and put a finger mark on it. You can see how much dust was on the mirror. That mirror was looking down at the ground, and it was the reflection planes of the three engines on Surveyor meeting at the middle of the vehicle caused the ejecta to blow up the center of the vehicle, and it was an open truss airframe, and so it blew right up and hit the camera. And then these are some etches, some lines that were etched into the mirror, permanently etched in by the impacting sand particles. We've also done experiments shooting lunar simulant at different materials, carbon fiber, Kevlar, glass. These were just fun projects we had an intern doing just to demonstrate that lunar soil is very damaging. Okay, so this is a simulation of a particle, I think it was a realistic particle of lunar soil with a spectrum of velocities based on the best available modeling. The circle is the moon, and this is where it's landing. And you see the ejecta starting to blow out at these low elevation angles. And so it takes about an hour to go all the way around the moon, but that's where the ejecta goes. This is a 2D cross section. So that shows how it goes all the way around the moon, and then it continues to rain in for weeks, because some of these particles that were close to escape velocity have a very high periseline. And so they take a very long time to go around. Now, this simulation ignores all the other perturbations, Earth gravity, sun gravity, solar wind. So this wouldn't really happen like this. This is now looking, we're going to zoom out. This is the putative orbit of Gateway, NASA's Lunar Gateway, and here's the moon. And so just to show it on that scale, this is the same simulation. The ejecta crosses the orbit of the Gateway, and it hangs there for weeks. We don't know how fast it'll clear out because we've never had anybody do a study of how fast does the space environment clear that dust out. But if it doesn't get cleared out, you could expect the gateway is going to pass through it maybe up to 10 times. You know, if it completes 5 orbits before it gets cleared out, then maybe 10 exposures flying through it. So when you calculate it, it comes out to about 2 to 10,000 impacts per square meter on the gateway. However, these are only like 10 micron particles and finer. And this not hypervelocity, because at that altitude above the moon, they're going very slow. And the gateway at an orbit at that altitude is going very slow. So the relative impact velocity is only half to a third of the speed of a bullet, way below hypervelocity. And so after 100 landings with 10 exposures each landing, it still only abrades 0.08% of the surface of a mirror. So maybe that's good enough. You know, 99.92% pristine mirror. I don't know. I'm not an astronomer.
What about JWST?
I don't know. I'm not an astronomer, so you'll have to tell me. But so we've done some effort to try to quantify it, but there hasn't been nearly enough effort. Low
Was there
lunar
a
orbit.
question back here?
You just answered it, so.
Low lunar orbit is much worse because now it is hypervelocity impact. The eject is still going fast and the orbital velocities are fast. So the relative impact speeds are way into hypervelocity, like 5,000 meters per second. And so when you calculate the flux and the number of impacts, after one exposure from a 40-ton lander, which is way below the mass of Starship, you would expect 256 million impacts per square meter. Impactor particles up to 15 microns or so, almost 6,000 meters per second. And so a significant fraction of the glass, 4% of the glass will be spalled on a mirror after one exposure or a lens. I assume that's not acceptable. I don't know. I'm not an astronomer, so I don't know. But 4% scuffing up your instruments is probably not good. Okay, so policy landscape. Outer Space Treaty is extremely vague. It says you shall not do any harm. Doesn't define what harm is. Basically, it's going to be impossible not to do harm because when you're landing on the moon, it's an airless body. You're shooting ejected to all distances. We probably should have a defined de minimis value, and below that value is okay, but we don't have that defined yet. The Outer Space Treaty also gives a right to inspect, so you're allowed to go up to any other operation in space to see what's going on so you can verify it's not a military operation. How do you land near somebody's operation without sandblasting it? You know, how do you exercise your right to inspect? So most people that are working on space treaties, from what I understand, they don't believe we're going to get a better treaty. The world is not going to agree to a new treaty. And so we have to work with what we've got. And there's going to be a big effort to create customary international law by establishing precedent and getting nations to start agreeing to it as the interpretation of the Outer Space Treaty. And so there are efforts going on now. About 5 different nations have passed laws interpreting the Outer Space Treaty. The US, Luxembourg, United Arab Emirates, Japan. I'm missing 1 or 2. But anyways, there's a number of laws that have been passed. Then there's the Artemis Accords, which is an international effort the US State Department initiated. We're trying to get countries to agree to join us in a framework that will establish precedent in the way that we together think it should be interpreted. And so part of that framework is what they call safety zones. And so when you're working on the moon, you're allowed to declare that you need a safety zone of so large around your outpost. Now, the Outer Space Treaty says you're not allowed to claim territory in space. And most people think that that applies to commercial companies and individuals as well. So if you can't have territory, then you can't have property rights. So, but the Artemis Accord safety zones is an attempt to come up with something that will not cross that boundary, but yet still give you some way to manage what's going on around your hardware. Unfortunately, not all nations are agreeing to it. There's another parallel effort, the International Lunar Research Station, which is led by China. It includes Russia, a number of other countries, and some private companies. So there's two competing efforts to establish precedent, which is like the worst possible outcome. Yes.
Question. So basically, it's kind of the Artemis Accords and the efforts you described, they seem to assume that the Outer Space Treaty will remain in effect.
Yes.
Is there a possibility that countries will just withdraw from it when it's no longer serving their?
Yeah, great question. So the Outer Space Treaty allows you, Article 9, I think, allows you to withdraw from the treaty, and all you have to do is write a letter to The Hague, and you're effectively no longer bound by the treaty 1 year after you send that letter. And unfortunately, a year is not enough time to respond. So if a country wanted to claim territory on the moon, they could get their mission ready, and then the day before launch, they could write a letter to The Hague, say they're withdrawing from the treaty, and then we see the mission going to the moon and setting up, planting flags and setting up boundaries, and you don't have a year is not enough time to get there and park something in their area they wanted to claim. So that's one of the reasons the Outer Space Treaty is not really a good treaty. It was a low Earth orbit treaty. It wasn't a beyond Earth treaty. But that's the situation we're in right now. One of the big uncertainties, I'm going to just fly through this, but why does it matter? Is there going to be a lot of economic activity in space? And I've published papers on this. And if you make rocket fuel out of lunar ice, it's going to take 5 or 10 years to start to get your hardware ready to go to the moon. Even if you had your funding, it would take you 5 to 10 years at least. And then it's going to take you some years of operation. So the vertical axis is years of operating, producing revenue. The horizontal axis is location in space, where 0 is low Earth orbit, 6150, I think, is meters per second is lunar south pole, lunar surface. And so we want to deliver rocket fuel to, say, geostationary transfer orbits. You can boost spacecraft, and it'll be another 7 years or so of operation before you can outcompete Earth launched. And so it's going to be 20 years before you've got a business case, probably. But I've analyzed it with very broad variation in the economic parameters. And I had a lot of economists and business people read the paper before I even sent it to a journal. And in all economic scenarios, lunar cost drops faster than terrestrial costs, even as launch costs from the Earth is going down. Lunar cost drops faster because launching the capital of the moon also goes down with launch cost. And there's some nonlinear effects. So anyways, looks like there's going to be a business case for mining on the moon, but it's going to be a few decades away. People have looked at full factories on the moon, and notionally, how would you make products? But even as far back as 1980, NASA Ames did a study. They could build a factory that could build 80% of its own mass using just lunar resources. And this was before we knew about ice on the moon. So they didn't even account for the ice. So the question is, how long till you get to big factories, and how long till you get to a big supply chain in space? I've done a lot of work on this, and I've tried to sketch out my guesses. Slow growth scenario, we're going to very, very slowly build the supply chain until by the year 2100, it'll be sufficiently large supply chain and rapidly scale up. That's the path we've been on. Rapid bootstrapping is if you have enough visionary people to pour money into it, even though you're losing money in the early years, you could probably get to that ignition point by 2050. And it's really not that much. It'd be like $2 per person per year for the 2 billion wealthiest people on the planet, something like that. It's not super expensive to do. It's just that nobody really has the vision to do it. But I think this is the most likely one. We're on the slow growth path with some pre-economic investment, and then nations are going to wake up and realize it's coming. And so when does that wake up point happen? Once you hit that wake up point, then you basically shifted this bar over by that amount. And so we could maybe get this ignition point by around 2070. But I was predicting the wake up point might be around 2040, but we're seeing signs that it's happening now because DARPA is already publishing, funding studies of lunar economic activity. China is all in for building large outposts on the moon. So I think several governments in the world are starting to do this investment. Okay, so now brainstorming. Let's brainstorm what are the geopolitical impacts of rocket blast on the moon. And so for an analogy, Australian Navy ships recently sailed through the Taiwan Strait, freedom of navigation operation. China disagreed with them doing that. So to respond in kind, they performed a live fire naval exercise off the coast of Australia. Australia only found out because a Virgin Australia airline pilot flying over saw that the Navy ship firing its guns below and reported it. And so a whole bunch of airlines got rerouted. So it's a relatively minor event, but I asked AI to come up with a way to estimate the costs, all the different cost categories, operational costs, airline utilization loss, cost to passengers, indirect economic costs. And it's estimating $1.4 million. 20 to 50 flights were provided from this very minor event. So when you go to the moon, everything's like 1,000 times more expensive. So we could be talking billions of dollars of costs for these geopolitical signaling type events. So if somebody says, we're going to go land on the rim of Shackleton Crater to prove we can do it, to prove they can't keep us out, then you could cause billions of dollars of damage. Damage to the landers, damage to surface infrastructure, damage to orbiting spacecraft. The cost of moving an orbiting spacecraft, I looked into how much fuel would you need to use to move to LRO, the necessary width to miss the ejecta, and it basically would use up like 70% of the operational life of propellant. And so you'd be losing a huge chunk of the value of that spacecraft if you move it even once, that amount of delta V. Anyways, there's environmental impacts. Another one is a lot of people think, well, we're just going to build the landing site farther from the outpost rather than build a landing pad. We'll build it farther away and we'll have the astronauts walk or rove. And if you figure it's a 30-minute travel time, I've gone through the numbers on this. I'm currently working on a project trying to quantify some of these costs using analogies and such. But just the increased travel time walking back and forth to your outpost, where is it? Yeah, increased travel distance, $9 billion of loss of value by using crew time walking back and forth if you have 20 landings at a lunar outpost, 20 landings and 20 launches. So, okay. So I just want to get your inputs, I guess. What do you think could be the potential geopolitical impacts of countries arguing over territory, arguing over safety zones? Oh, another example. Let's say that you have solar panels up in the lunar South Pole region and somebody wants to land over here. Well, what you could do is turn all your solar panels edge on to the ejecta. And so you could estimate the amount of time that you're losing power because they're turned away from the sun and the loss of value. You don't over design everything beyond, certain margins. And so if you're going to decrease power collection due to blast events, then you have to have larger margins and there's a real value loss there. So it's another example. Okay, so I'll skip the rest. Peaks of eternal light are going to be very highly contested areas. Are they de facto territory?
Oh, that's great. I mean, those are thought-provoking questions about some of these things. Christopher,
Yeah, before venturing into the geopolitical, one technical question. So you mentioned mainly the properties of the regolith, but what are your thoughts about potential contamination from the propellant itself? Again, we were looking at the Artemis system. They talked about the area of disruption being like 100-meter radius, which was very small. But if you're trying to then collect things like pristine samples of ice or pristine samples of regolith and understand like the composition, particularly of the volatile species that are there, what happens in your view with the volatiles that are associated with the jets?
Yeah,
Because-
so Parvati Prem at John Hopkins or Maryland, anyways, or Goddard. She's doing analysis of that. She's using DSMC model. And that model, so if here's your lander coming down, the model's valid as long as you're high, but the model's not able to do the final moments as you're getting low to the ground. You're driving gas into the soil, and then that gas is going to be coming back out over the next month or so. Trying to analyze those other near surface events are very difficult. We just don't even have models that we can reliably use yet. Also, you're driving volatiles into the grains, and then the grains are being ejected. So you're transporting these volatile infused grains over a larger area. I don't know if that's going to be a significant source of volatiles evolving over the next couple of months or not. And then there's also the plume gases directly freezing into the PSRs. So to put it into context, I've done the calculations on one Starship landing. The mass of propellant that you blow into the moon's gravity during one Starship landing is 10 times the mass of the lunar atmosphere. So one landing. And so if even 1% of that gets sequestered in the moon somehow, then you've created 10% perturbation to the lunar atmosphere. Yeah, so it could be very significant, but I can't give you any more details than that, I guess.
Just makes sampling pristine moon very difficult.
Yeah. Unfortunately, there's no other way to land right now than using rockets. I used to, when I was at NASA, I used to try to think of, are there ways you could use rocket fuel made with different isotopes so that you can sort out the contamination from the natural materials. But unfortunately, if you want to measure the isotopes of the natural materials, then whatever isotopes you use in your rocket exhaust are probably also going to be in the ice. So I'm not sure if that would really help. And plus the cost of using different isotopes in your rocket fuel would be really expensive. But
Jess, is there, I mean, from the lunar samples, is there any evidence of like the rocks that were disturbed or the samples disturbed by the landers? Have people thought about that for what's been collected?
I don't think so. One of the ways that you would probably try to look for it is to look for organic contamination, and at least the lunar soils we have and samples we have right now, they're so organically clean. They're cleaner than even our standards on Earth. So at least right now, it doesn't seem to be a problem. But if we have a Starship landing or 10, then yeah, things might start to change and we might start to see it.
How much can you use the topography to limit damage?
yeah, a good question. So first of all, so when we wrote a document, how to protect the heritage sites on the moon, it's a NASA document getting recommendations for how to land on the moon to protect the heritage sites like the Apollo sites. And we put in that document that if possible, you should try to land behind some terrain feature that will block the spray. But I haven't seen very much analysis of how effective that will be. One problem you get into is that in vacuum, dust does bounce. So dust particles hitting a larger particle, significantly larger particle, they'll bounce off. And it should probably, depending on the amount of fracture that occurs, it'll bounce off with less kinetic energy. But typically geomaterials have an 80% coefficient of restitution. So the velocities will end up being 90% of what they were before. So it's still really fast, but they scatter into all directions. I've done some calculations on what fraction of the ejecta will bounce. And it's like 70% of the particles smaller than 10 microns will probably hit particles that are large enough to bounce them off. So you'd probably get like a 30% reduction in flux, and then the flux is spread over a much larger solid angle. But it doesn't completely stop it. I haven't seen any quantitative analysis of how much damage it'll do to the thing you're trying to protect, or how much it'll improve the protection.
There was a question online as well.
Yeah. Actually, Jacob, why don't you unmute? I think I saw a question from you go by.
Hi, very interesting talk. I was just curious, did you do any analysis on like an approach angle of the exhaust plume? So if you had the landing thrusters at like 45 degrees instead of perpendicular to the landing surface, does that change the amount of dust you kick up?
Yeah, good question. This has come up. There were some experiments done back in the 1970s at Langley on they call it the cant angle. Starship is planning to land with upper thrusters up around the top of the vehicle, and those will all be canted out at some angle. I've done some calculations on the how it changes the spread of ejecta where the plume hits the ground. You still get ejecta blowing in every compass direction, but it'll be like elliptically distributed. So most of it will go in the downrange direction, but a small fraction will blow back towards the vehicle still. If you enforce conservation of mass, momentum, and inertia, that's the solution you get. There will be some blowing back at the vehicle. And we've seen that in experiments. So it doesn't completely solve it from damaging your own vehicle, but it does put more of the ejecta outward. And by the way, Starship is not going to avoid blowing dust by putting its thrusters higher. I think they're like, I'm guessing by, putting a ruler up against the pictures that SpaceX published, but it looks, if I recall, it looked like about 20 meters of extra altitude, and then slant range is maybe 25, 30 meters. And then if you look at what altitude did the Apollo lunar module start blowing dust, it was about 31 meters. And then that was a 7.5 ton vehicle. Starship is going to be like 150 tons, which is, what is that, 30 times, 40 times the mass, so 40 times the thrust. And so I'm estimating that it's going to be blowing dust from very high, and it'll be blowing dust all the way down. And so in a sense, canting the engines out actually makes it worse, because you can't build a landing pad that's big enough radius now to contain the impingement points. And so by putting the engines higher and canting them out, it does reduce the total flux of dust that you blow. It doesn't stop it entirely. And if you want to stop it entirely, it's unfortunately, you can't build a landing pad that's that big. It would be cost prohibitive to build a pad that big.
Thank you.
Vic?
Yes, this is Vic Baker. We're very fortunate to have a specialist in international space law in our online observers. It is Professor Tanibi Aganaba from Arizona State University. If Tanibi is still with us, are you still there? Tanibi?
I think
Can you unmute? Yeah.
I think we lost her right as you lost them just as you said that.
She might have been turned
Oh, that's too bad. Yeah, Tanibi is a specialist in international space law at Arizona State University. She is particularly interested in African nations and their interest in international space law. But she attended the talk, and maybe she had another meeting to go to. But maybe she will get in touch with you later about this very interesting issue.
Yeah, I'd be happy to talk to her. So this is not really the subject of today's talk, but I'm trying to direct a new institute that got stood up, which is trying to democratize space, trying to get more people around the world to have equity in space. Because going back to that chart of how long until there's a real ignition point for space economy growing, if this timeline is correct, we've only got a limited number of decades to democratize space, because once you hit the ignition point, the industry is going to be robotic, so there won't be any labor. And whoever owns the capital will be able to use the industry to build more capital and scale it up very rapidly. And so there won't be any motive or mechanism possibly to dilute equity after that point. So if we want space to be democratic, I think we need to work very proactively right now in getting more people to be owners of what happens in space, people all over the world.
Well, this sounds excellent. And Tamidi has actually done a lot of scholarship on exactly that topic. I can put you in contact with her. My email is just baker@arizona.edu. So stay in touch.
Okay, great.
Yeah, I wanted this fascinating too, but I wanted to go back a bit to the geopolitical aspects that you brought up. And so you put up safety zones being de facto territories. And so can you walk us through what is I'm imagining here what may happen is that nations reserve certain ranges, territories on the moon as their potential landing zones, and then they basically warn others not to land there because of the potential safety concerns. There's a question how large these would be, how long-lived they would be. What else would happen? What are the other geopolitical considerations, or how do you see that play out? What are the risks?
Yeah, so there's also an economic issue that people aren't going to want to invest in a mining operation unless they know that you have secured the rights to that resource. Because if somebody swoops in and takes away half of your resource, all those investors could lose their money, go broke and lose all their money. So so people in the business world want to have some system of claims on resources. That's a separate issue, but it is intertwined with safety zones, because setting up safety zones is one way to create a de facto claim over the resources within that safety zone. So here's I think it's a funny story. When we did the Google Lunar X Prize analysis and we wrote that document protecting the historic sites on the moon, Rob Kelso was the person, NASA headquarters, designated to chair that committee. And one day Rob asked me, Phil, if you come up with a number, what is the number of kilometers distance or meters that you have to land away from the Apollo sites? I told him, well, I really can't answer that because the science isn't really solved yet. We don't know how far the ejecta goes. And then even if we did, we don't know how much damage it's going to do. And how can you ask me to say what damage is acceptable? You need historians and anthropologists and archaeologists and ethicists and the public to make that decision. I can't tell you this much damage is acceptable on these precious historic artifacts. And he said, you got to give me a number. we can't publish this document without a number. And I said, well, I can't. I'm not going to do it. I'm not going to put my name on a number. And he said, well, how far is it to the horizon on the moon? And so I calculated, it's like 1.6 kilometers or something, 2.4 kilometers. I told him, depends on how tall you are. And he said, okay, a 6-foot tall human, how far to the horizon? And it was like 2-point-something kilometers. So he said, okay, we're going to round it to 2, and that's our number. So that's literally where the requirement came from in that document. We were at a conference at a poster session, standing in front of a poster, and that was our conversation. And it was a rounded off distance to the horizon for a 6-foot human. It has nothing to do with the actual damage that you'll cause. Can we do better in the future? Can we define realistic safety limits? I think we can. I think we're getting closer to being able to, but it's very subjective. It depends on the hardware, how much damage the hardware is going to receive based on the materials it's made out of. What are the operational requirements of that hardware to be functional, to not reduce its lifetime more than a certain amount, and that depends on the criticality of the hardware. So it's going to depend on every different type of equipment. Like if you build a really sensitive telescope in the middle of Shackleton Crater, you might start demanding 50 kilometers, because to protect the mirrors on that telescope. So I don't know. I think it's going to be messy trying to get the world to agree on protocols for this.
Where is this sort of state of understanding for the effects of vacuum detonated nuclear weapons and what the effects would be on the lunar surface at different altitudes and yields?
You know, Kuiper was part of the study to detonate a nuclear bomb on the moon
Really?
in the early 60s.
Yeah, I really don't know. I have no insight into radiation, nuclear radiation. What are your thoughts on
Inevitable.
it?
I think it's one of the biggest issues with being able to do anything on the moon. The degree of exposure is just crazy. So how do you harden an environment so that people are willing to be able to invest? So part of that comes down to is it defensible and is it? Most of the concepts, I mean, they're limited subsurface environments that you can begin to occupy, but I can't see that it wouldn't be an issue. But it's a different type of contaminant. It's a different type of risk. There are a lot of intuitions we have about the effects of nuclear weapons that are biased in terms of what happens with an atmosphere. But in a vacuum environment, how would you need to be able to build something that would be secure against a dispute of claim?
Yeah. So I think it's possible that in the long run, decades in the future, the killer app for space economics could be data servers, AI computing, because most compute isn't going to be harmed by a 2 or 3 second time delay on its final output. Like training an LLM might take 9 months, and if you add 3 seconds, that's negligible. But so most compute could be off the planet. I think in the long run, as launch costs go down and as value of AI goes up and as environmental impact costs of sprawling data servers and sprawling energy collection to run all the servers, as that cost, the environmental cost goes up, I think it's going to be naturally driven off the planet. Already, I haven't checked these numbers, but a friend of mine at Langley told me that the value produced per kilogram of data server is already higher than the launch cost per kilogram. So it's not crazy to talk about putting servers in space. But then that brings up the issue about how vulnerable your servers are to adversaries from EMP. So I have wondered a little bit about that. But anyways, I do think in the long run, like, I don't know how many years or decades in the future, I do think data servers in space are going to be a thing. And I think it will end up being the majority of our civilization's economy will be compute off the planet. That's why I think we got to democratize it, because if the majority of economic value is produced off the planet, then how do we make sure that enough people own it in order for democracy to survive? I think that's a really hard problem.
On the computing topic, how much of the resources can you mine in the moon to build computers so you don't have to bring everything?
Yeah, so it really depends on developing how developed your supply chain is. So all the elements in the regolith could be extracted. People have notionally developed chemical processes to extract all the different elements from all the different minerals and from the ice. I can show you spaghetti charts of the material flow on these. People have put together integrated diagrams of all the material flow for full lunar industry and full asteroid industry. So nominally, if the elements are there, then you can get them. The issue is most of the technologies are TRL 3 or 4. So they need a lot of investment before they get up to the point that you would start using them in space. And then it's going to take years of using them in learning efficiency before it becomes really economically efficient. So that's why it's going to take decades before you get a real supply chain in space. But there are some elements that are missing from the moon, or they're not common enough. Like the carbon in the ice is very small amount of carbon. Nitrogen is very not abundant on the moon. Those are probably the two worst ones, carbon and nitrogen. So you would have to augment your manufacturing with material from the Earth or asteroids or comets or something. Mars has carbon and nitrogen, I guess. I'm not sure about where's the nitrogen. Is it in the atmosphere? Is there a small amount of nitrogen in the atmosphere?
I don't know.
I've heard Mars has a lot of nitrogen, but I've never bothered to look up what that means. Anyways,
I don't think you'd have fabs like chip fabs on the moon, right? You'd make the chips here.
yeah, it's a matter of the percent closure of your industry. Like that NASA summer study of 1980, they aimed for 80% closure. So chips and other electronics would be made on the Earth. But they were making their plans would include making solar cells from regolith. I mean, that has been demonstrated. There's a company called Nana Electric in Europe, which is currently taking contracts for providing power for people on the moon using solar cells that they make out of regolith. And they've demonstrated making solar cells out of, I think they said 99.8% regolith, 0.2% brought from Earth. They've demonstrated it. So just an example that, you can get a lot of the mass from space, from the moon. But it's a big economic problem. The problem is there's no real business cases that are incremental. The whole thing doesn't become economic until you've got enough of a supply chain. But how do you develop a supply chain if there aren't any incremental businesses to build it up? And so it's a coordination problem. And that's why it's very uncertain how long it's going to take until you get to that point.
So it seems like a lot of the economy in space now is tourism. And that strikes me as something that could happen here too, but or the fact that we want to preserve some parts for science. But whenever I see the agreements like Artemis or whatever, it's all seemed to be based on industry or mining. And it just strikes me that what chaos if we had like tourists, trying to go to the same locations, some of the caves and stuff that are also like major exploration, mining.
Yeah, I agree. I really believe we need to have the government be proactive to regulate it. And I've heard people dispute this, but some people in business claim that they welcome government regulation on these issues because at this point, there's only uncertainty. And uncertainty does not create a good environment for getting investors. So the sooner the regulatory environment becomes clear, then the easier it'll be for these companies to begin operating. But you mentioned the scientific value. If you have companies just landing out of control in the PSRs, blowing rocket exhaust everywhere, you could ruin the scientific value of those samples. And so it's really important. Now, if we do it right, if we regulate it appropriately, then the economic activity could be a huge boon to science. Because right now, we only visit one small body every 2 years, roughly. But if you had companies that were mining asteroids, we might visit 20 a year. And so we could increase our access to data by multiples, many multiples. And I've done analysis of the role of economic versus academic earth science, geological science. Went to the Bureau of Labor Statistics and I went to other sources. It's like 95% of geological research is economically driven and 5% is purely academic. And even the academics are supported by the tuition of the 95%. So, and then there's other arguments too, but so it could be a huge boon to science, and it could also be very healthy for our field because if we have jobs to go to that are not just all academic, then academia won't be such a pyramid scheme. So, so we can graduate more than one PhD student in our career and not overpopulate the job pool. But
CLIPS is already hiring some, the CLIPS providers. So.
Yeah. So I think it could be very healthy, but we do need to have the government manage it. It'll be the tragedy of the commons if we don't.
One more follow-up. So in addition to mining and industry and science and exploration, there's also the military aspect, potential military use of the moon. So it's often said that the moon is the ultimate high ground. what are your thoughts on the military strategic importance of the lunar presence, establishing it both in terms of on-surface interactions between nations and then also lunar, terrestrial, or cislunar space control?
Yeah, I don't really have any great insights into that. I have participated in a couple of studies. The only insight I got is that space makes everything worse, because if you have a kinetic war, then the debris that you create, in zero G and it's just it's a horrible thought to going kinetic. And so you want to set up a situation where you can prevent going kinetic. And how do you do that? Do you have the military go in from the start and establish order, or do you keep away completely? And I don't know. I don't have any answers to that, but I do. There is a fundamental question here about the nature of law, because here on the Earth we have disagreement over what the laws should be. Different people have different laws, and the way we disentangle that is by having territory. This law is applicable in this territory, a different law in a different territory. So if we disallow territory off the planet Earth, we have to create a completely different regime for managing laws. So I don't know. Some people have argued that the Outer Space Treaty is going to fail. It'll go away. People will be ignoring it. Some people told me it's already failed, but nobody's acknowledging that it's already failed. That countries are secretly violating it all the time. I don't know. I have no insight on that, but I don't know. It's a lot of important questions here.
Recently, there was this asteroid, and it was determined that it has like 10% chances of hitting the moon in 2032. Are there any discussions on these kind of scenarios?
I'm sorry, I didn't listen well enough because I was still thinking about what I just said previously, and I distracted
the asteroid
myself.
that might have hit the Earth that was in the news, and then the orbit was refined and it would miss the Earth. But it still has, I think it's still today has a chance.
Yes.
No, not Apophis. It's
a different one.
A different one in 2032.
2032.
It still has a chance of hitting the moon. So it's like, what if there's a big asteroid impact on the moon compared to some of these other,
Yeah. So there are other risks for operating on the moon, like that. Micrometeoroids and meteoroids of all sizes are worse on the moon because there's no atmosphere to filter it out. Radiation is another big problem. We don't have the atmosphere to protect us from solar events, and also the cosmic ray flux is worse on the moon above the atmosphere. But then another one people don't take into account is lunar quakes. They got some lunar data during Apollo, the Lunar Seismic Network, and they measured a power distribution of these events. There was one type of event in particular, and I feel stupid talking about it because there are true experts in the room and I'm not. but I talked to the guy who, I forget his name, Japanese name, from Houston. He was the lunar seismic guy during Apollo. Anyways, he said that there was one type of event which is associated with the rims of large impact basins, because the rims are still geologically unstable and settling. And he said over like 100-year timescale, you could expect city killer earthquakes based on projecting that power law. So I don't think we've really factored that into our thinking either. I'm sorry, I'm not giving any answers. I'm just broadening the problem.
No, it's good. It's a very mind expanding to think about these.
Yeah.
And you think of like Antarctic exploration, and you have failed attempts. If we have failed attempts to establish something at the lunar poles, and everybody dies or is abandoned, is that then you still go land, or is that still protected? Or
So when we started the Google Lunar X Prize analysis, trying to figure out what to tell Google about visiting Apollo sites, at first the lawyers, the NASA lawyers, didn't want to touch it. In fact, they told me, don't even bring it up. If you bring it up, then it's going to go to the UN, and we don't want to go to the UN because the UN might tell us we're not allowed to go to the moon. And so do not bring it up. And so eventually we convinced NASA to address it and make voluntary guidelines. And the NASA lawyers didn't want to do anything other than voluntary guidelines. But over the course of a few years, they became more confident that they had a right to claim protection of the hardware. And so eventually it became a law to follow that document. So Congress passed a law and the president signed it. So the legal people have been getting more confident in believing that they can enforce some kind of protection on the moon. But it's still evolving.
Well, I think we should probably stop it there, but thanks so much, Phil. It's really
My pleasure.
very thoughtful. It's great to hear what some of these ideas are, the things that.
We didn't really talk about mitigation. I just want to show you that there are various mitigation methods. So if you've got people working on this, bulldozing, sintering, infrared microwaves, baking pavers and ovens, gravel beds, polymer application, and they all scale close to equal economically. So that's an area of interest that people want to work on. That's very important. I think there's going to be a need for building on the moon.
Cool.
Okay, thank you.
Okay, thank you.